Hi, and welcome to a new statistics nugget. Today, we'll explore a key concept for anyone working with data: conditional probability applied to dependent events. If you want to understand better how users behave, optimize marketing strategies, or reduce uncertainty in your decisions, this nugget is for you. Let's start with the basics. What is conditional probability? It's the probability that event B occurs, knowing that event A has already happened. Think of dominoes. If the first one falls, it increases the likelihood that the next one will drop as well. Conditional probability helps us update our expectations when we already know something has occurred. It's widely used in science, business, finance, and marketing. Let's clarify a significant difference. Two events are independent when the occurrence of one doesn't affect the occurrence of the other. For example, flipping a coin twice. The first result doesn't influence the next one. Dependent events are different. What happens first changes the probability of what happens next. A classic example is drawing cards from a deck without replacing the first one. Recognizing this difference is essential for using conditional probability correctly. Now let's look at the key formula. If we want to know the probability that both event A and event B happen, we multiply two things: the probability of A and the probability of B given that A has occurred. In other words, the probability of A and B equals the probability of A times the probability of B given A, or P of A and B equals P of A multiplied by P of B given A. If we want to find just the conditional probability, we divide the probability of both events by the probability of A. So the probability of B given A equals the probability of A and B divided by the probability of A. And when the two events are independent, the probability of B given A is just the probability of B. Let's apply this formula with a simple card example. What's the probability of drawing two hearts in a row from a deck? For the first card, we have 13 hearts out of 52 cards. That's 25%. After drawing one heart, there are 12 hearts left out of 51 cards, around 23.5%. Now we multiply. 25% times 23.5%. That gives us about 5.9%. So, the probability of drawing two hearts in a row is much lower than it may seem. Now let's look at a real-world example. Say 20% of your website visitors spend at least 100 euros. Of those, 10% get a gift card. The probability of both events happening, spending 100 euros and getting the gift, is 20% times 10%, which is 2%. This joint probability is always lower than each of the individual probabilities. It's a good reminder that every step in a funnel affects the final result. Why use conditional probability? In marketing, it helps estimate how many users will complete a conversion path. In data analysis, it's used to segment users or build predictive models. In finance, it's helpful to update the probability of a risk or return. In decision-making, it helps you reason more accurately when new information becomes available. It's a powerful tool that helps you make better informed decisions. Let's summarize the key points. First, conditional probability applies when events are dependent on each other. Second, the formula is the probability of B given A equals the probability of A and B divided by the probability of A. And third, if A and B are independent, the conditional probability isn't necessary. Remembering these three things will help you use this tool with confidence. Here are three common mistakes to avoid. First, don't confuse the probability of A given B with the probability of B given A. They're not the same. Second, don't apply the conditional formula to independent events. It's unnecessary and can mislead your analysis. Third, always remember to update your probabilities after the first event, such as when a card is removed from a deck. Avoiding these errors will make your analysis more accurate and reliable. Let's try a simple, practical exercise. In your e-commerce site, 15% of users click on a promotion. Of those, 20% make a purchase. So the probability of click and purchase is 15% times 20%. That's 3%. Now, imagine your click-through rate increases to 25%. The new joint probability becomes 25% times 20%. That's 5%. This shows how improving just the first step in a funnel can significantly boost final results. Try applying this logic to your data. That's it for this statistics nugget. If you found this helpful and would like more practical mini lessons, visit my academy. You'll find content designed for professionals who work with data daily. Subscribe to the newsletter to stay updated, or follow me on social media, especially on LinkedIn and Medium, where I share tips, tools, and real-world examples. Thanks again for watching. See you in the next nugget.